And I think for this kind of event, some of you are here for the first time, so I want to say a word about the Simons Institute. It was founded in 2012 by a generous grant from the Simons Foundation, and they have supported us all this time for the foreseeable future as well. But meanwhile, we do get support from industry sponsors and individuals, and we thank all of them, and we hope to get more funding so that we can keep going forever. The Simons Institute is unique in computer science because it's a place that brings together theoretical computer scientists, but also people in allied areas that we can approach from a theory point of view. It brings them together for a sustained collaboration. You have lots of workshops that happen for a week and then people leave. But here, people come together for a semester. And the idea is that we bring together people with different perspectives, and maybe some new directions can emerge from research here. So what we consider home runs are new research ideas that emerge from a program at the Simons. And we've had many of those over the years. So when we have a program like this semester's program on federated and collaborative learning, we are talking about technologies that have a profound impact on society, policy, and maybe law as well. And we have the ability to have something called a Law and Society Fellow. It's a person who kind of straddles technology, but also maybe policy or law or philosophy, who might actually, interact with the technical people about the societal impacts and policy implications of the technology we're discussing in the program. This semester, very rarely, and fortunately, we are happy to have two different Law and Society Fellows sitting right here, and I'm going to introduce them each. Rui-Jie is a PhD student at Brown University. And let me just pull out some information, sorry. Okay, and she works with Suresh Venkatasubramanian, who has been very active in the area of fairness and works with the ACLU and so on, so very appropriate for this program. She's affiliated at Brown with the Center for Technological Responsibility, Reimagination, and Redesign. And her research focuses on the intersection of artificial intelligence, policy, and law. Greg Demirchyan is an attorney specializing in technology law. He's the CEO of Fair Logic, which is a consulting firm that advises companies on AI governance, responsible AI principles, and the emerging landscape of regulatory requirements. So those, I guess there's a much longer bio I could go into on each one, but that gives you a general idea of where they're coming from. Greg is also a philosopher by training, so he also brings that angle in. So please join me in welcoming Rui-Jie and Greg, and I'll hand off to both of them.
Thank you, Sampath. I'm really excited to be here to talk about alignment problems in AI governance with Greg. And to kick things off, I'm going to be talking first about this piece of technology. Does anyone in here want to tell me what this piece of technology is or what it can do? Yes, the Sony Betamax. Back in the day, if you wanted to watch your favorite TV show and it aired at 2 p.m. on a Wednesday and you were at work, then you missed your favorite TV show. But this VCR tape let you copy that television programming and watch it when you got home from work. But in the 1980s, television programming rights holders sued Sony for the ways that its VCR tape was used to copy and distribute their programming in ways that it alleged violated their copyright protections. And this case went all the way up to the Supreme Court, where the Supreme Court ruled that because the VCR tape had this substantial non-infringing use, that of time shifting, that of copying your television programming to watch it later, that Sony should not be held liable for downstream copyright infringement. And this was seen as a great thing for producers of home video technologies, as well as for producers of dual-use technologies more broadly, technologies that could be used to infringe on copyright, but that also had this substantial non-infringing use. And this became known as the Sony Safe Harbor. And it was certainly the hope for Napster, which was a peer-to-peer file sharing service, that they would fall under this safe harbor. But in the 1990s, music rights holders sued Napster for the ways that its copyrighted music content was being uploaded and downloaded on its servers. And Napster tried to argue that they fell under the Sony safe harbor. But the courts ruled that because Napster had control and knowledge, because they had this centralized file directory of the files that were being shared, that Napster could not fall under the Sony safe harbor, and they would be liable for downstream copyright infringements. But then Aimster rolls around. They hear that knowledge is the reason why Napster is being held liable, and they decide to encrypt the files that are being transferred in order to claim that they don't have knowledge over the files that are being shared. And the court kind of said, nice try, but if you don't know what files are being shared, how do you know that there's this substantial non-infringing use? And Aimster was also held liable for downstream copyright infringements, and that was kind of the end for Aimster. But then Grokster comes around, and Grokster's like, the centralized file directory seems to be why Napster was held liable. Why don't we decentralize our file directory? And this case really miffed the courts. This case went all the way up to the Supreme Court, where they had to come up with this whole new legal theory in order to hold Grokster liable for downstream copyright infringements. And why I'm spending so much time telling you about technologies that aren't AI is to point to this dynamic of using code, using technologies like encryption, of using decentralization as a kind of anti-regulatory mechanism. Now, what is an anti-regulatory mechanism? There are two kinds of anti-regulatory mechanisms. One kind of anti-regulatory mechanism includes mechanisms of avoidance. Mechanisms of avoidance that bypass legal requirements or make these requirements harder to enforce. And these tactics include things like tax evasion or sophisticated tax avoidance strategies. Another kind of anti-regulatory mechanisms include mechanisms of change, which are mechanisms of legal influence that help secure favorable regulatory arrangements, such as lobbying. And Professor Wu's intervention in his article, When Code Isn't Law, is to suggest that peer-to-peer code can operate as a kind of avoidance mechanism. Now, in this talk, I'm going to be talking a little bit about how AI's code in this current landscape can also serve as a kind of anti-regulatory mechanism, as both a kind of mechanism of avoidance as well as a mechanism of change. And I'm going to be doing so in two parts, talking about some of the work that I've done during my PhD. Starting with mechanisms of avoidance and red teaming AI policy, a taxonomy of avoision, and the EU AI Act. And this is work that I did jointly with Bill Marino, who's a PhD student at the University of Cambridge and a lawyer, and my advisor, Suresh. And here, I'm going to start with a little bit of a provocative quote, which is that power interprets regulation as damage and roots around it. And as we saw before, there are lots of ways that this rooting around can happen, through lobbying, through sophisticated tax avoidance strategies. But the kind of rooting around that we focus on in this paper is that of avoision, the avoidance of laws in ways that evade the law's intent or purpose, but that don't actually constitute unlawful behavior. And in particular, we were interested in avoidance strategies in light of the EU AI Act. Why the EU AI Act? Well, as we were writing the paper, there were some signs that regulated entities under the Act were trying to maybe avoid the EU market, stall certain features, remove AI from the EU market more broadly. And so to think about how these behaviors perhaps might subvert the goals of the EU AI Act, we introduce a taxonomy of avoision, which includes 3 tiers. At the very top, there's this bundle of avoision strategies that might allow you to fall outside of the scope of the EU AI Act. And then we talk about avoidance strategies that would allow you to fall within the exemptions of the EU AI Act. And finally, we talk about different avoidance strategies that would allow you to kind of arbitrage between different consequential categories of the EU AI Act. And I want to note that as we move down these different tiers, there's this increasing exposure to the EU AI Act that regulated entities face. Now, for the sake of time, I'm going to be focusing mostly on the last tier of categories, consequential categories, arbitraging between different consequential categories. Now, the EU AI Act is famously this risk-based approach to regulation. There are high-risk AI systems and low-risk AI systems. There are general-purpose AI models with systemic risk and general-purpose AI models. And typically, the more risk you have, the more regulated you are. And the goals here are to minimize threats and to promote market diffusion. Well, One way that you might be classified as a general purpose model with systemic risk is if that model has high impact capabilities evaluated on the basis of tools like benchmarks and indicators. And one way that this threshold could be avoided is by shopping for benchmarks where it looks like your model may not have these kinds of high impact capabilities, or through model sandbagging, where your model might know that it's being evaluated and look like it doesn't have these kinds of high impact capabilities. Another way that a general purpose AI model might meet the threshold of systemic risk might be through if the computation used for training is greater than 10 to the 25 floating point operations. Now, I'm going to be talking a bit about federated learning here, which is a technology that I know that a lot of you hold near and dear to your hearts. But federated learning here could be used to kind of split the computation among many different entities so that it's harder to account for the total amount of floating point operations used. Now, another kind of category in the EU AI Act is the categories of operators. So there are different operators as part of the AI value chain. There's the deployers and there are providers. And the goals here are to sort of ensure that there are sort of proportionate responsibilities, that proportionate transparency measures are laid down. And providers have the greatest amount of requirements. And one way that an operator might take on provider responsibilities is if that operator makes a substantial modification to an AI system. Now, one way that this threshold might be avoided is by constraining the types of technical changes that you're making, even if the resulting model behavior is still changed significantly. So this could mean prompt tuning rather than fine-tuning on an additional data set. So that kind of concludes my discussion here. I'm happy to talk more about it later, but I'm going to be talking a bit about mechanisms of change, and specifically how the kind of science of AI safety might be framed in a way that is sort of leveraged against regulatory oversight. And this is work that I did jointly with Dr. Brian Judge, who's a political scientist here at UC Berkeley. But to talk about sort of how the science of AI safety functions as a mechanism of change, we have to first understand sort of how these technology companies would like regulations to change toward. And at the very bottom, we have restrictive legal regulation, curbing or banning deployment. And then we have moderate technology regulation. And then at the top, we kind of have no regulation at all. And so I'm going to be talking a bit about how the science of AI safety might be leveraged in a way that enables these companies to maintain the kind of status quo of no technology regulation or moderate and voluntary kinds of technology regulation. So what is the status quo right now? Right now, companies are employing things like the preparedness framework and a responsible scaling policy. And these things have been called if-then commitments because there are frameworks such that if their models are evaluated to have certain types of capabilities, then a certain set of technical safeguards kick in. And these frameworks and policies depend a lot on the science of AI risk and the science of AI evaluations in order to determine whether they meet that threshold or whether they meet a certain capability threshold. But how is this science being wielded as part of lobbying documents? Well, companies have sort of advocated for the pushing forward of the science of AI risk reduction. And the science is rigorous, but it is nascent. But because of this nascency, they've also used this to kind of defer regulation and to advocate for developing research in AI risk, and also to advocate for voluntary and innovation-friendly approaches, such as those pursued by the US AI Safety Institute at the time, now the Center for AI Standards and Innovation. At the same time, these companies are also funding research in this area through their nonprofits like the Frontier Model Forum, which has like this AI safety fund. And so as they advocate for the investment in this kind of science, they themselves are also developing this kind of science that they can then potentially point to when talking about scientific rigor and nascency that helps them kind of maintain this kind of self-technologically regulated status quo. So it seems like I just listed a bunch of problems. I think the thing that I want to draw your attention to here is that there is a lot of emphasis on the primal path on which the law is applied. But then there's this kind of dual path through which the law can be avoided. And it's a core steering mechanism as well for how technologies, like privacy-enhancing technologies and technologies that purport to enhance safety, are developed. And I think I'm here to kind of underscore the importance of technical expertise too in kind of differentiating between different use cases and steering technology development towards the public benefit. Thanks. And I'm going to hand it over to Greg to talk more about regulatory misalignment.
Okay, thank you very much. I'll be talking about a very specific problem, which is what's called the regulatory misalignment problem in governance. So governance of AI system is a really, really hard problem. And as a result, many kinds of misalignments result, one of which is what's called a regulatory misalignment. And what is regulatory misalignment? Basically, it's a kind of a misalignment or poor fit between the regulation and its intended target. Usually the target is some kind of a harm that you're trying to mitigate, prevent or mitigate. And of course, the problem with why you want to avoid misalignment is that misaligned regulations are likely to yield poor or ineffective governance. So there are different kinds of regulatory misalignments. This is just maybe a subset of that. We can think of many, many more. But one very prominent one is what's called a technical regulatory misalignment. And this is basically where there are these technical gaps. A proposed regulation it will require a technical solution that either doesn't exist or isn't sufficiently effective to achieve the regulatory objective. Another kind of misalignment is deficiency in institutional capacity. So you have regulators, you have agencies that are tasked with oversight, but the regulators may not have the technical expertise. And that's a very serious problem because obviously the technology we're working with that they're trying to regulate is very, very complicated. They may not have the bandwidth. Sometimes there may be issues with respect to authority if there are multiple agencies involved in oversight. There may also exist informational asymmetries between regulators and developers. All of that makes it hard for these regulatory institutions to do their job. There are also definitional gaps. That's a very big problem. Sometimes the target harm isn't defined at all or poorly defined, making the connection between the regulation and the harm very imprecise. There are also value trade-offs. So, for example, collective implementation of these regulations that individually aim to maximize or to maximally protect a certain value, let's say fairness, privacy, safety, may run into trouble because of conflicts among these regulatory objectives. So trade-offs or some kind of prioritization among values may be inevitable. You have to do that. So what are we looking for, right? We want evidence-based regulations. But the world we find ourselves in is such that the evidence is still quite incomplete. So what do we do? Does this mean that we should wait until some high threshold in evidence is reached before we propose regulations? Industry, a lot of people in industry or who talk about regulation from that standpoint essentially they think that there's not enough evidence, and so we have to wait until the evidence comes in. The problem with that is, this technology needs to be regulated, in my opinion, and we are dealing with decisions under uncertainty, right? And the problem is there's always going to be some amount of uncertainty that we have to deal with. So that's a constant. And so if we wait until we're more or less certain about the technology, we may have to wait a very, very long time. And I think that's really not a good way to do governance. And also uncertainty can get worse. And if we decide, for example, to take catastrophic risks seriously, rational choice theory will say you may have to take a radical approach to governance. You may have to wait to deploy until we have a good way to deal with such risks. I mean, the rational thing to do politically, it's a non-starter, right? So we're finding ourselves, what I think, between these extremes, like wait until we have great evidence and then regulate, versus don't deploy and we need to do more research until we understand the technology, and then obviously we'll have the right regulations, and also we can deploy these models at that time. I'm trying to sort of find a more balancing position, that is, let's try to regulate and work with, where there is uncertainty, there's some uncertainty, but we still have some evidence, and therefore we can still make these models maybe not safe, but safer, maybe not fair, but fairer, and so on. So that's kind of what I think is perhaps is sort of the moderate position. Yeah. Okay, so the technical gaps. This is, I think, an example of asking for requiring technology that's not quite there yet. So Article 55 of the UI Act says providers of general purpose AI models with systemic risk shall perform model evaluations in accordance with standardized protocols and tools reflecting state of the art, including conducting and documenting adversarial testing with a view to identifying mitigating systemic risks. All right, so this is a notion that somehow we can really identify and mitigate these risks. Well, I don't think that's right. I don't think we're there yet. So currently we lack a comprehensive understanding of frontier models. And this, of course, makes it hard to provide a full accounting of the potential risks. So there's a black box problem. We don't really know the right computational structure within neural nets. And so we can't really zero in on those internal computations that would explain and predict model behavior in a consistent and reliable way. So in other words, if it's not like a car engine where you look and you can figure out, okay, these are the problems and you can predict the risk. That's we're dealing with something much more mysterious. And so again, we're not quite there. We don't quite understand the internal mechanisms of these models as a way to provide explanations and predict risk. What do we do instead? Well, developers use externalized behavior, like chain of thought reasoning, to evaluate model safety. But research suggests that this often fails to reflect models' internal processes. And so chain of thought reasoning can potentially be misleading and unreliable. This is a faithfulness issue. Also, effective interventions and risk mitigation methods are still quite inadequate. Safety tuning has significant shortcomings. So, for example, you can identify a bunch of dangerous capabilities and knowledge, but mitigating and sort of erasing those capabilities is still not an easy thing to do, is work in progress. Now, I have some open questions, like, well, if we cannot trust chain of thought, what do model capabilities really tell us? Can we trust our accounting of risks? But also this is more philosophical. Should the faithfulness issue be a concern for us at all? Can we just rely on the externalized behavior as a way of telling us how these models function? Do we really have to look into the, as it were, brain of the model to figure out what's going on? So there's also the other form of misalignment where you have many definitions but no consensus. So AI Act, New York, and also there are lots of examples, and proposed laws that focus on algorithmic fairness and says basically something like individual entitled to fair, non-discriminatory systems. But no definitions are provided, or even a set of definitions sometimes, because I think ultimately we're going to have to deal with a set of definitions of algorithmic fairness, and that's context sensitive. And because of their multiple, probably, definitions we have to contend with, some of them are conflicting, and moreover, suitability of a definition is going to be, like I said, context sensitive, requiring that its scope be accurately defined. And so the tricky thing is, and this is again, I see this problem as very much a possibility. You're going to have multi-jurisdictional regulation with respect to fairness that might codify incommensurable definitions. So California, for example, will define fairness in one way, and then New York in another way, and they may conflict. And so what do you do in those cases, right? You can't, it's simultaneously you can't satisfy both definitions. So you have to be careful that you don't end up with this sort of incommensurable definitions that's being implemented cross-jurisdictionally. Also, leaving a value like fairness at the level of general principle shifts the burden of operationalizing definitions and metrics, no surprising to private actors, who can then game the system by implementing standards that are easy to meet but don't really advance fairness. So, in other words, if there's a choice of a bunch of metrics and the regulations don't say which one, you're going to end up with developers essentially doing something like fairness shopping. They'll choose whatever metric is easiest for them to satisfy. There are also tensions and conflicts with respect to realizing multiple values. So there's a privacy bias trade-off. Identifying bias requires demographic data, but privacy data minimization principles make accessing that data difficult. There's also accuracy and fairness subject to certain definitions. Models may face this sort of direct tension between being accurate and being fair. So again, trade-offs are needed, and they're inevitable, but current regulations don't seem to anticipate kind of working out that problem of trade-offs. So here's a very incomplete roadmap to alignment, very, very incomplete. As I said, we have incomplete understanding of these models, very, very incomplete. So we need a lot of research. We need to generate a lot of knowledge. So one thing, of course, is fund research on critical gaps in understanding of models. Also, what I see is there's a lot of work being done by various communities. The research communities that focus on safety, for example, but they're fragmented. And sometimes when you're dealing with a fragmented ecosystem, right, that produces knowledge, it's really hard for agencies to figure out who to trust, who to listen to. And so what you want to do is you want to kind of bridge that and create a more unified system. And then, of course, you would want that to be independent, and you want to prioritize well-evidenced interventions. And also, you want there to be some kind of reporting on well-evidenced, centralized reporting of well-evidenced interventions. That way, these agencies will know where to go, and that also will ensure that they get the right expertise. So, building a robust centralized pipeline between the research community and regulators to ensure the following. So the regulators have the expertise to evaluate compliance and risk management practices that are being implemented. And also regulators are kept informed about the latest developments in risk mitigation and intervention. I think these are fairly modest proposals. Now, developing a robust ecosystem for third-party auditing is also very helpful because there's a kind of a division of labor here, which you add additional expertise, but you also alleviate some of the burdens of compliance oversight placed on regulators. require developers to be more transparent about their emerging capabilities and report adverse events. That's a good thing because you can learn a lot from that. Don't leave things at the level of general principles, as I mentioned. Instead, make hard choices and make clear positions on definitions and value trade-offs. And then something like adaptive governance. I have another slide for that, but I'm not sure if maybe I can. Do I have time for that? All right. I'll just briefly mention a few things. So the other thing I'm thinking is you know, you need regulations to be flexible and to be able, and you can, that are adaptable. So you want technological flexibility. For example, regulatory framework has enough flexibility to adapt to new technologies. As new sort of information, new knowledge comes through, and there is, especially if there is like something like a scientific consensus, then you clearly want the regulations to adapt to these technological updates. Also, it encourages collaboration across research communities to build unified understanding of effective interventions. And you want to build repositories where, for regulators, so they can go and really understand what are effective interventions and what the rights, so that they can update the standards for compliance. Risk profile customization. So risk profiles of frontier models can be determined by evaluating their capabilities, their technical capabilities, and the socio-technical context in which they're used. You can sort of shape the standards and protocols for safety in such a way that they're adjusted based on the risk profile. And with respect to trade-off, this is a hard problem, but I think more research needs to be done on this. At least aim to locate the value trade-offs along the Pareto frontier and allow flexibility where it lands, and where trade-offs happen to fall, that could be something that's jointly determined between developer and regulator. This is something like, you know, similar to the kind of process that the FDA. There are many differences, but at least there is that similarity of kind of this dialogical negotiations taking place between a regulator and the developer, and that allows for a lot more flexibility. You want post-deployment monitoring, of course. I think that's a wise idea. You want adverse event reporting, as I mentioned, centralized incident database, again, because that could be a very important repository for understanding what goes wrong, what went wrong, and then from that you can learn about how to make models safer. You want continuous oversight too. And because as it interacts, you learn a lot more about the kinds of risks the models pose. Verification and auditing, another good idea, but you want, of course, third-party auditors. You want independence. And periodic reporting, you want developers to provide, again, unified periodic reports incorporating the latest advancements in safety, privacy, interpretability. And then this is the last thing. This is about value alignment. How do we achieve that? This is a different kind of alignment. This is value alignment. People talk about how do we train for models to be moral agents? That's, I think, a very, very hard problem. So, but if there's any value in this kind of value alignment, I think we should start by making models follow the law at least. That's a very hard problem in itself, and that's something that Rui-Jie and I are thinking about. That's about it for me. And we have, yes, yeah.
Suggesting that we go straight to audience.
Okay, yeah. Thanks. Questions?
We're going to have Q&A with the audience now. And I'll bring around microphones, so if you have a question, just raise your hand and I'll give you the mic.
Rui-Jie, I had a question about the federated learning example you mentioned. So I'm not sure if I understood it correctly. So is the main ambiguity there that when you decentralize computation, then these companies could say that we don't fall under a particular category where we should be regulated because we are not performing as much computation in a single data center? Is that the...
Yeah, that's kind of the gist of it. We kind of took this example from Dr. Sarah Hooker in her paper about compute governance. She's discussed the use of federated learning as well in this context to maybe obfuscate accounting. So when computation might be split among multiple entities, exactly as you said, you might be able to be in a situation where you don't hit that 10 to the 25 floating point operations in your single data center, but like cumulatively you do. And there might be room for such an argument to be made, yeah.
Yes, my question is, don't we also have a problem of moving targets in the way that the dangers that are coming from these systems are changing a lot? In 2018 or so, everybody was talking about fairness and data privacy and people, not being denied a loan because the AI decided they wouldn't get it. And which is still a problem. But then these new LLMs came around and they turned the whole educational sector upside down, or they're going to kill Hollywood. There are so many new problems arising. And I think, for example, the European AI Act was made in under the dangers, the first kind of dangers that I talked about. And they worked for years on that, and then they came to some conclusion, and then this new technology popped up, and maybe that's what you mean by flexible legislation, that you have to come up with ways that you can react very quickly to these new things that are popping up left and right.
Yeah, that's exactly right. These emerging capabilities arise. They pose additional risks and that were completely unforeseen, right? Who would have thought that models could be deceptive, could be scheming, have a sense of self-preservation, all of that. All of those capabilities present novel risks. And so all of a sudden, you want to, so when from a governance standpoint, you want to be able to assess what the risks are. And that way you can then say, okay, given the risk, this is how we address these risks. So it's very, very, very important to be able to have an accurate accounting of risks. And that's not an easy thing. And then, of course, once you identify the risk, what's the intervention, right? That could, oftentimes involves a technological response. And so you may not have the technology, so you have to kind of stimulate people to do research and come up with the technological response to the risks that you identified. So it's a constant evolving thing. I mean, technology. We're talking about LLMs. We're talking about transformed technologies, but maybe a year from now or 2 years from now, we'll have a completely different architecture. And then again, we have to think about, well, what are the risks? What could be the emerging capabilities, and how do we address that? So it's that's why this is the hard part. Law moves very slowly, so we have to rethink our framework. Like, how do we accelerate the pace of these regulations? If we really intend on regulating, how do we do that? And because ultimately, we don't want stagnant regulations, right? We want dynamic, evolving regulations, because that's what is required to make them effective.
I also wanted to add an additional point. Greg and I have also been talking about this notion of planned adaptation. There are some regulations and standards that have embedded in them that 5 years from now we will revisit these standards again and think about whether they're still relevant. And 5 years might be, 5 years might be a really, really long time in the scale of AI, but that kind of spirit is really important too.
Okay, so my question is more or less exactly the question that was asked earlier. It's mostly been answered, but I have one additional piece of it that I want to ask. Are there instances in the history of society where law has moved quickly, like maybe at the dawn of the Industrial Revolution or something, where there was a system of re-examining laws frequently and changing them?
I don't think there are many examples that I can think of. So the couple of examples that were given about for example, so the EPA needs to check for to retest for pollutants and make sure that the harmful effects of air pollutants is updated. That's in the Clean Air Act. That's codified. And again, that takes into consideration that, look, things change, and so we need to make sure that when we're dealing with people's health, that we're effective in implementing these regulations. So that what is the ultimate purpose? We want to make sure the air is clean. And there are other examples, but there are very few. I mean, it's just. Even if you have an adaptive process, right, something like that, the bureaucracy still is going to churn very slowly, and so my worry is that even with an adaptive approach, it's still going to be, it might still be slow.
I think here there might be something to be said about maybe how existing laws are enforced and when paces in enforcement change.
Yeah.
That there might be the sense that things are quickly moving and quickly updating. And so that is also a really important area to consider for sort of adaptation.
Yeah, and I think institutional capacity needs to be really improved. You may have a kind of a more adaptive framework, but if the agencies aren't doing their job, or they're too burdened, they're not doing it fast enough, or let's say recommendations are made, like NTSB, for example, can make recommendations about safety. But are those recommendations, listened to? Fortunately, they are for the most part, but in other cases, institutions may actually move more slowly.
This is maybe a question sort of following up on that in a way. Looking at some history with regard to law and regulation, business practice regulations that ultimately fed Sherman antitrust in the late 19th century. This invention of the railroad that turned out to be a nice choke point for intermediate goods distribution led in part to a reaction on the part of and growth of farm labor parties because there was interest in terms of farmers to get their product to market. Similarly, in pure food and drug regimes, currently, while we think of that as operating at the individual level in terms of feeding your kids stuff that's not going to hurt them, when it's institutionalized in a distribution chain, then intermediaries are very concerned about the quality of the good that the grain that they receive to put in the barley in their Campbell's soup. Could we, and what that's built on is intermediate standards that businesses, well-funded, knowledgeable entities who participate kind of as co-equals, more or less, can grow to understand and flesh out the understanding in terms of harms and mitigations of harms, and standards that goods, in this case, perhaps services as well, could comply with to reduce that possibility. Do you see anything in B2B transactions, as you mentioned, the value chain? Is there any hope there of sort of B2B standards helping us out here?
Yeah, interesting question. I haven't really thought about that. Yeah. I don't think I have a very good answer to that, but I mean, the only thing I see happening is, if there's some sort of a bottleneck for some, and you have or a safety concern, then there's going to be economic consequences, right? For let's say the developer of the model, you would think, and that might prompt the developer of the model to make additional take additional safety measures. But there's also the issue of liability. I mean, to me, the one thing that really is I'm sure lawyers working for these companies are thinking about, like, what happens if something terrible goes wrong, right? We're going to be liable for damages if it. So that's also creates an incentive to build safer models. My concern is that it's the developers of these foundational models that have that in mind, because they're large companies and they're wealthy companies, whereas a lot of the companies that build agents, a lot of them are startups. To them, the liability is less of an issue, because if something terrible happens, they don't have the money, so they go out of business, but they're willing to make that risk, right? So the liability works with some companies, but not with others. And also, if you're building something that and you're selling it to other businesses, and those things create problems for those businesses, right? That will have an economic impact on you. So there may be some feedback, positive feedback or virtuous feedback to improve safety. Yeah.
This is, sure, a naive question, but underlying the myriad difficulties in alignment and responsibility for innovation and so forth, all the technical issues, to what extent is there a more or less universal agreement on the values that these mechanisms are designed to implement? I mean, does everybody agree on what fairness consists in? I'm sure it's certainly not the way with me and my 5 children, so I think that it's certainly not the way with a larger society. And in your discussion, it seemed that the foundational issues underneath the technical ones, well, that's my question.
Yeah. Do you want to take that?
That's a great point. I think rather than maybe speaking to the foundational kind of issues that are very much real about like how fairness should be defined, I was mostly interested in how these technologies are being framed. So even if there is disagreement about whether or not this technology is achieving fairness or privacy or security, they are sometimes nonetheless being framed as achieving these things, where they may have other kinds of uses in the kind of anti-regulatory kind of spirit.
One thing this is a very important question that you asked, and it's a very hard problem. And again, this goes to value alignment. And for a philosopher, the first thing that pops in mind, okay, which values? That's one thing, and then of course, how are you defining them? So even if you agree on the values, how you define them is very important. Fairness brings that up, right? So there are many definitions of fairness, but there's no consensus, and that's reflected in the proposed laws. No one wants to make that commitment. It's like, be fair. Well, how? Let's wait until the technical specifications. So, for example, the EU AI Act, kind of defers that and presumably the definitions will come in the technical specifications. which they recently came, but there is no, I'm not sure, I'm not even sure whether to call this technical specification, but there was kind of an opinion by one of these standard organizations, standard building organizations, that said, okay, this is what fairness means. There are multiple definitions. It could be equal odds, it could be this, it could be that, but no commitment. And so again, it doesn't really, what do you do as a company when you're not told what fairness is, how to comply? The other thing, of course, is the even bigger problem when it comes to value alignment. Value alignment. So one thinking is we need to train models to behave as moral agents, right? But again, as a philosopher asks, well, which morality? I mean, people disagree about all kinds of things. And also there are cultural differences. I mean, suppose, we have some maybe consensus on what the right value is and what the right values are and what should be required of a model in terms of its moral conduct. But when you go to a different society, it may have a very different perspective on that. So one worry is that you're essentially kind of importing. It's not even, the other problem is that we're talking about very few companies kind of making decisions about what the right moral values ought to be. And then imposing it on us, of course, the rest of society. But then, of course, that also means imposing it on other societies who may have a different view of what's moral. So it's a very hard problem, and that's why I think maybe that's not the right way to go. But I think it's a great question and a very hard problem to solve.
Okay, so I have a few parenthetical remarks. So liability, I think, is a very powerful tool. Mm-hmm. But as you probably know, the vast majority of tech companies disclaim liability altogether. So you mentioned Sarah Hooker. Sarah Hooker's company disclaims all liability for the actions of its AI systems, and she didn't even know that. So it's just such a knee-jerk reaction for the people who write the contracts in the tech companies. Microsoft not only disclaims all liabilities, as in any circumstance, we will not pay you more than $5, right? Which is just a sort of a poke in the eye, right? So one of the most important legal processes to ensure safety of products is non-functioning in this industry. Okay, that's parenthetical remark number one. Number two, I don't think value alignment means what you think it means. The word value is not like, well, Christian values or Islamic values. The word value is like utility and economic theory, right? So it means having AI systems that act on behalf of what the people who it's going to affect actually want the future to be like. So that's what it means. And so this argument, well, whose values and, the companies are imposing one set of values, I don't think that's the right way to think about it.
So value alignment can be interpreted in many, many ways. There's a very narrow way of basically make sure that the model does what the developer tells it to do. So that's a kind of another form of alignment. But then there's a form of alignment that you mentioned. But I also think people, when they talk about value alignment, they also mean kind of you want to make sure that the models behave in an ethical way. And that's a form of alignment with our human moral values. Yeah.
Yeah, but I think that's exactly what gets you into trouble. I don't think that's what the original meaning of the phrase alignment actually was referring to. Anyway, so those are two parenthetical remarks, but I want to talk about what I see as a looming conflict between our right as human beings to protect ourselves and the view of the technology developers, which is basically we haven't the faintest idea how to make these things safe. So you, the human race, are not allowed to protect yourselves by requiring any form of safety guarantee. End of story, right? That is the current debate that's going on. And you don't often hear it stated exactly that way, but when you push, the companies will say, well, we don't know how to do that, so you can't make a rule. And if a nuclear power plant operator said, well, we don't know how to stop these things from blowing up, so you can't have any kind of safety regulation on our nuclear power plants, we would say, well, I don't think that conversation would last very long. But right now, the government has completely bent over and said, oh, yeah, of course, anything you say.
Maybe
this is going to be the conflict. They have $20
maybe
or
not
$30
that
trillion
it can be
to
entirely,
spend.
not that they don't entirely know how to solve this problem, but that they frame this problem as being able to be solved through this kind of rigorous science that only maybe they know how to do, and that is still very nascent, and that it still needs a lot of investment. And that is the reason why we don't have, that's how they push this argument to maybe try to avoid other forms of external oversight. And that's how they have pushed this argument.
They will, but when they are pushed, they will say, you can't make a regulation unless we know how to comply with it. And that's just a fallacy. They can comply with it by not deploying an unsafe product. No other industry will get away with this argument. The drug companies.
There are other arguments, right? Kind of adjacent arguments, which namely, we're kind of an AI arms race, and so if you overregulate us, our adversaries will develop, much better, much more powerful systems.
Our adversaries who have much stricter regulation than we do.
Exactly. And which my
So
response is...
It's a sort of fictional narrative.
Yeah, but China regulates AI quite strictly. So, when the actual arguments are so poor, but that's kind of the state of the discussions, the dialogue that's taking place. It's between the billionaires, and they have the bully pulpit, and they kind of lead the discourse, unfortunately. But here we're here to change that, I hope, one step at a time.
So I wonder if what your thoughts are about something concrete and recent, which is companies like Anthropic coming up with a constitution for their LLM Claude. Is that likely to bring better alignment, or is there another strategy that may actually deflect regulation in some way?
Yeah. So constitutional AI, as I understand it, is a kind of technical kind of safeguard. And in fact, there's been some research from the Irish Council for Civil Liberties by Dr. Chris Rui-Jie that has kind of shown how members of the EU Parliament have discussed constitutional AI from Anthropic as a method to ensure that the sort of outputs of Claude sort of fulfill the sort of Declaration of Human Rights. It's almost seen as this substitution, this kind of technology as a substitute for regulation. And so it's been viewed this way already by regulators. Yeah.
So if you can elaborate more on that value thing, why it's so hard, because I kind of agree with him that maybe the cost is so small for these companies, because not only the Constitution, now they know very well when the models can deviate from certain behaviors. Mm-hmm. Very good research available. That's how they code very well. Mm-hmm. They don't produce bad code, they produce good code and better code. So we know 20, 30 personalities, personas model know very well. Why do you think it's so hard? Because we make it too philosophical maybe, or too theoretical, as opposed to looking at practical harm? If you could just elaborate more on that. Looking at the harms, yeah, I mean,
one way is to ensure that when we identify what harms these things are capable of doing, that there are enough guardrails to prevent them from doing that, right? There's a more ambitious project, I think, and that is, well, we kind of, the models themselves will internalize those guardrails, right? If we train them to be moral agents, then they're not going to misbehave, right? One is they're capable of misbehavior. How do we prevent that? But the more ambitious project is they won't misbehave, right? We're going to train them not to misbehave. And that, I think, is a much harder problem. I don't know how else to put it other than, it's from kind of a more philosophical standpoint, it's really hard to train. I mean, how do you train something that exhibits a very alien form of intelligence, right? They're very different from human beings. And training human beings to be moral beings, is very hard and often doesn't succeed. Even if if a human being knows what the right thing to do, sometimes they'll choose not to do that. So, with models too, one thing is their conception of morality. I mean, no matter what you do, it may just be very different because they conceptualize the world differently. So how do you impose this kind of a concept of morality which may be entirely alien to them? So that's a kind of more general philosophical question, issue. And so, that's and even if you succeed and kind of, if they not necessarily internalize, but they know what the moral right thing to do, as they become more autonomous, more agentic, they may choose not to do that because, again, there may be certain, propensities or dispositions that they develop, capabilities that they develop. They'll say, thank you, thank you for, maybe you want me to do the morally right thing to do, but I'm driven to do this something else, which will deviate from that. So, it's just a hard problem, and I don't really see how it can be done.
So we are really out of time. We're out of time, but we can take one last question
Okay.
and continue the rest of the discussion outside.
I'm sorry.
Last question.
One of your slides said regulators shouldn't ask for things that are technically impossible in some way. There was a golden age in regulation for cars when California set the standards for the whole world, basically, and they were asking for things that every car manufacturer said, impossible, we can't do that. And the answer was, okay, then your car won't get approved, so put some research into that. But in order to be able to do that, you have to have a licensing process that you can't put a car just in a store, everybody can buy it. With these models, they just put them out into the world, and there's no seal of approval necessary. Maybe that would be the first thing to ask for, is you can't publish something like that unless you prove this or that. And if it's impossible, then we have to wait for 5 years until you can prove it.
Yeah. It's upside down, yeah. I think it's the way it's...
So you can't help us.
This is industry capture, right? A lot of the work is, this important work is being done by these companies. If you think of the Manhattan Project, right? There, it wasn't really industry. It was state-funded research, and unless the thing was relatively safe, you wouldn't use it. But there wasn't that sort of, the incentives were not, okay, we need to make money, we need to deploy, we need to bring these things to market. That incentive wasn't there. Here, these companies are doing really important research, and so, but they also are in the money-making business. So, it's really hard for us to say, okay, do the research for now, but don't deploy, because that might take a very long time, and they're expending a lot of money, So if they're the ones in the driving seat, as it were, on policy, then you see the result, right? They'll just deploy these products without making sure that they're safe.
Thanks to Greg. Thank you for a great discussion. To the audience.
In short.